So currently I'm just lerping the rotation degrees to the rotation value. Rotations don't really work well with lerping though. As you can see when I was moving around my player, it kind of was like spinning around sometimes, and that's not the desired rotation we want. So I did find a fix. We're actually going to define a special function for this. This function, lerp angle, gets the from, so where we're lerping from, where we're lerping to, and the weight we want to lerp from. So this will be using math to calculate how we're going to lerp into that other angle. So let's define our other function below it. So below lerp angle, we're going to do short angle distance from and to. So it finds the shortest angle to lerp between, because you saw it before when I moved my player and I turned my mouse, he would sometimes not go the shortest path to turn there. He might have like spun around the opposite direction to get to it. So this will get the shortest distance to lerp it nicely. So now that we have these functions in, we need to change a couple things around. First of all, I'm not going to be using rotation degrees anymore. So let's go down here, and when we are set the rotation down here, we're going to want to set this to rotation instead of rotation degrees. And then we're going to go up here, and instead of rotation degrees, we're going to say rotation equals lerp. But instead of lerp, we're actually going to use our new function, lerp underscore angle, add our rotation to our puppet rotation and to delta multiplied by 8. This will make it so the players actually smoothly rotate. So let's test this. And there I am. And you can see I could spin around like crazy, and the rotation's interpolated way nicer than last time. It gets the shortest angle other than last time where it just like spin around almost 360 trying to get to the other angle, right? So you're going to want to rename this line edit to username text edit. And then we're going to set our text to enter username. So we'll have a username system, and our IP address that we'll be entering in the manual setup will already be here. And now we need to change a couple things because we just renamed that in the script. So instead of server IP address, we now need to call it the username text edit, right? So we're just going to say, we're going to rename this to username text edit. And instead of server IP address, we're going to say username text edit. Now we're going to make some changes because the UI is going to be changing, and our old code is no longer going to work with this new system. There's going to be a couple things that we're going to change. On the create server side, right here, we're going to have to check a couple things before we actually create the server. First, before we actually get into changing the network setup a bit, we're going to have to define a variable in the network. So go to the network.gd script. This is the preloaded network script that everything can see. And we're just going to add in our variable under IP address. We're going to say current player username, and we're just going to set this to empty text or to empty string. And that's all we need in here. So we save this. We're going to go back to network in a little bit, but for now we're going to go back to network setup. All right, now what we're going to do is when we create the server, we want to make sure that the username textedit.text is not blank. So we want to make sure the player enters a username. And then what we're going to do up here is we're going to make sure that we set our current player username in our network to the text edit text that we put into it. When we enter our username right here, we want to make sure that we set that right here back to the current player username, so we'll be able to access it in other scripts knowing what our username that we put in. Now down here in join server, we're going to change this up a bit. We're going to make sure that username text edit instead of server IP address, username text edit.text is not blank. And instead of just hiding the multiplayer configuration UI, we're also going to need to hide the username text edit. So we want to make sure that's hidden, and we're actually not going to join the server yet. So right here we do create a server because we haven't figured out exactly which server we're going to go to yet. So remove this code. We don't need it here now because what we need is we need to be able to see the server browser. We want to be able to find the servers that are on the network, and we want to be able to manually set up a server if it's not showing up. So instead of joining the server, what we're going to do is we're going to tell global to instance the node, the server browser. So this entire scene right here, we want to instance this on top, and we're just going to be instancing it. And the parent of this will be ourself, which means the network setup is going to be the parent of the server browser. So it'll just create that server browser, and you'll be able to browse the servers. We can play it, and we can actually see when I hit the join server button, we want to make sure we put in a username, because if I try to click it now, it's not going to do anything. So let's put in our username, test, join server, and it's going to give me the server browser. And a lot of these elements will be hidden. So it's a little cluttered for now. Don't worry, it won't be that way when we're working on stuff. Now we have the server browser set up. We need to make it so the server browser is actually able to find servers. All right, so the next thing that we're going to want to do is we're actually going to add a new node. So add a new scene, and we're going to do another node. This is just going to be a node a normal node, not node 2D. We're going to rename this to server listener. We're going to add a script to the server listener and we'll hit create. We can also save the scene, server listener.tscn. We'll hit save. So we're going to have two signals, new server and remove server. These are going to be custom signals. We're going to set them up in a second. We're going to have a cleanup timer, and this will clean up the servers that are inactive. So if we close the game, right, we are hosting a game, we want to make sure that the server listener knows, hey, this server isn't available right now. It must have gotten shut down. And this cleanup timer basically waits a certain amount of time if it doesn't receive a packet from the host, and then it will shut down. We're going to set up a socket UDP. This is going to be our packet peer UDP. We're going to set a listen port. This is just going to be the default port that we use in the network. And this known servers dictionary will carry the data of the name of the server, the IP address of the server, and basically that's all it needs. We're going to make another variable. It's going to be server cleanup threshold. This is 3 seconds. So if we don't receive a UDP packet in this 3 seconds, we're going to remove the server. You can fine tune this value as much as you want. You can make it higher or lower depending on whatever works for you. In the init function, we're just going to say that the cleanup timer.wait time equals server cleanup threshold. It'll basically just set the time of the timer to the cleanup threshold, which is 3, and then it'll set one shot defaults. And then we're going to set auto start to true, so it automatically starts. Then we're going to connect the timeout signal to ourself. We're going to call it cleanup, and we're going to add the cleanup timer as a child. In the ready function, we're going to clear all the known servers, just going to make sure that we start on an empty list of servers. And then we're just going to put a couple of debug notes down here. So once we listen into this socket UDP at our port and it's not equal to okay, that means there was an error listening on that port, and the port's probably already being used by another service. So that will just let you know. And if you ever have that happen, just make sure that no other applications on your computer are running on that service, and just check your browser settings and stuff. There might be some issues with Godot permissions and the firewall on your computer, or even the firewall on the router. In the process function, we're going to get the available packet count from our socket UDP. We're going to make sure that it's greater than 0. We're just doing this to make sure that there is another packet that we haven't gone through yet and that we can interpret that packet. So it gets the server IP through the packet's IP address that's being sent from. It gets the server port from the port that the socket is being sent from. And this is a low-level API. We're actually going to get a variable of all the bytes in the array, and we're going to get the packet of the UDP. We just want to double check and make sure the server IP is not empty and the server port is greater than 0. And then we're going to check with our known servers. If known servers does not have this server IP, meaning that we don't know the server, it's a new server, right? So we're going to do a server message variable, and it's going to string it. It's basically just a way of encoding characters from bytes and stuff, you know. Basically, it gets the string from this array of bytes. That's all you need to know. Then it gets the game info, and it parses the JSON file of the server message, which interprets it to a string. We basically save it, the server message, when we are sending out the game info. We essentially put it into a JSON file. And so what game info is going to do is it's going to parse this JSON file, our server message. And JSON is just a file format that's easy to send over the network. And so that's why we just save all of our game info into JSON when we send it out through the UDP packets, and then we just parse it when there is a new server. Because this is just a server listener, right? So we're listening to servers. So once we make the server advertiser that sends out the server information to all the clients, that will actually create the JSON file of the server message, and this will basically parse that. We're going to get the gameinfo.ip equals server IP, because IP is a variable inside this JSON file that we are parsing, and we're using that. So we'll just set the gameinfo IP address to the server IP. We'll set gameinfo.lastSeen equal to os.getUnix time. We'll tell known servers, we'll go in the array of known servers, and we'll tell it that the server IP is a known server, and we'll give it the game info. We'll emit the signal that there's been a new server, and we'll emit it with our game info attached to that. And then we'll basically just print the packet IP address. We're going to do an else right here. So we're going to set our game info that we saved in our known servers with the server IP index. Again, we saved all this game info from up here. We set known server IP with the game info. So we're basically just setting that back to the known server that we found. And we're just updating the last time we've seen the server. That way, if we haven't seen the server in a while, then we can just say, say, hey, that server probably got shut down or it's not responding and we need to time it out. All right, so we have a cleanup function right here. And this is actually the timeout function to our cleanup timer. So whenever our cleanup timer fires, we want to make sure that our known servers have actually responded within our cleanup timer time frame. Because if they haven't responded within 3 seconds, they either shut down or their internet connection is so bad we probably should not join it. We'll go through all the server IPs and known servers, make a variable called server info, and we're going to set that to known servers, this server IP in our known servers, because we're going through every single server in our known servers list, and we're going to get all of the server info and make sure that this server has been up long enough. Then we're going to do an if statement. So if our current time right now minus the last seen time that the server has sent a packet to our game is greater than the server cleanup threshold, remember it's 3. So if it hasn't gotten a packet from it last seen and it's greater than 3, that means that we're going to erase this entirely, and we're going to say, hey, the server's not responding or it's shut down. We need to remove it from our server list because we're probably not going to want to join this. All right, so we're just going to remove that old server with our server IP. So it'll just say, hey, we're removing this old server IP, and we're going to emit the signal that we have removed this server with our server IP. We just clean up the servers and we tell it, hey, the server has not said anything for the past 3 seconds. It's either shut down or the internet connection is too bad. It's going down. The last thing we have to do in the script is when it exits the tree, meaning we change the scene or it gets destroyed, the socket UDP closes. Because we want to make sure we've closed the socket UDP. There you go. We have our server listener. We have everything we need to listen for servers. Now we need to be able to send servers. We're going to make another empty scene. We're going to make a new node, just a node, just like the other one. So we're just going to rename it to server advertiser, and we're going to add a script, and we're going to just press create. This is in its new empty scene. We could save it as server advertiser.tscn. Hey, first thing we're going to do is we're going to set up a broadcast interval. This will be every 1 second. That means the host will broadcast all of their server data every second of the game. We'll have our server info, which is just a dictionary with the key name, and it's going to just be LAN game as the default. But this will actually change to the player's username. We'll make a socket UDP variable. We're going to make a broadcast timer, and we're going to make a broadcast port. Now, when we enter the scene tree, we're just going to set our wait time on our broadcast timer to the broadcast interval, which is 1 second. We're going to set one-shot defaults, and we're going to make it auto start. Next, we are going to check if the scene tree is a network server. And if it is, we're going to add the broadcast timer as a child to this node. And this will connect the timeouts of this timer to broadcast as the signal. So whenever timeout goes off, the broadcast signal will go. We're going to make a socket UDP, and we're just going to make a new one. We're going to set broadcast enabled. This basically tells it, hey, this is going to be a broadcasting UDP where you're going to actually broadcast to all the devices on the network. So just be ready for that. Next, this will actually broadcast it. So now that broadcasting is enabled on it, the destination address equals 255.255.255.255. And this big 255 address essentially is an address that tells the network, hey, if we ever send things to this address, the router is actually going to forward to every device on the network. So if I ever send to the 255 address right here, the router will automatically forward this back to all of the devices that are connected to it. This will make sure that our address right here, whenever we send stuff over on the socket UDP, it will go to 255 and it'll be forwarded to all the devices on the network. We're going to do our broadcast function. So broadcast is whenever the broadcast timer goes timeout, and every 1 second when it goes off. It'll set the name of the server info, which is right now is LAN game, to the network.currentplayer username, which we change in our network right here. Whenever we create the server in our network setup, whenever we create the server, it's going to say, hey, our current player username is this username textedit.text that we put in when we created the server right here, this text. So if we set our username, we're going to set it to our current player username. If I set my username to test, the current name of this game will be called test. The packet message will be a JSON file format, so it converts this server info, this dictionary, to a JSON file format. Then we're just going to set our packet and convert our packet message to the ASCII, so then it can actually be transferred through the network and read back to a JSON file. And the socket UDP will put this packet right here that we're sending when we're sending our ASCII ASCII packet. And when we send that, the server listener will see that and it'll say, hey, we need to parse this JSON, this server file. We're going to get the string of this JSON file from the ASCII, and we're going to parse this JSON file using the server message, which allows us to use these variables and get the IP address from the server IP. So now we send out that packet. We put the packet of our message. All our message is going to be is our current name. And then on the exit tree function, we're going to set the broadcast timer. We're going to stop it. And if our socket UDP is not equal to null, meaning our socket UDP does exist, then we're going to close it. So we got to make sure it's closed, because if we leave the scene tree, we don't want it to stay open. So we could save this, and we basically have our server advertiser and our server listener, and all that code is done. Yeah, so let's start actually making it so the servers start popping up in the server list. Now we have this server advertiser and a server listener. So let's go in our server browser, this root node, add a script, press create, and we're going to go back to our server browser scene just for a second, and we're going to actually add our server listener to this server browser. So I'm going to drag this in. I'm just going to drag this server listener.tscn right under server browser, and there we go. We have the server listener in our scene. Whenever we're in our server browser scene, we're going to want to listen for servers anyways. That's why we're going to throw in our server listener so it starts listening automatically. So we can go back to our server browser code. So we're just going to get a reference to our server listener. We're going to get a reference to our IP text edit. We're going to get a reference to our server container, which is our VBox container, which will contain all the servers in the server list. And we're going to get a reference to our manual setup button. Now, when this is all initialized, we want to hide the server IP text edit, which is this right here, because we don't want to see this until we hit the manual setup where we manually type in the IP address. We'll hide that in the ready event. We're actually going to have to connect some signals. So go to server listener, and if you remember, we actually created some signals in here. So if we go to node, we have a new server and a remove server signal. So on new server, I can connect that back to the server browser, and there you go. You have on server listener, new server. And we're going to do this the same for remove server too. We're going to connect this to the server browser. And now we have these signals all connected back to server browser, and we can easily get the data from the new server and from the server that's been removed. So for each of the servers that it searches for, it'll spawn in under here, and I need to create the UI for that. So let's do that right now. We're going to hit the plus button. We're going to add a label. We're going to rename this to server display. We're going to set our base font right here. So I'm going to drag that back in, and the default text right here is just going to be the not applicable 0000000. This is not needed. You can literally just put no text in here and you just be just fine. I just put this in here so I know how it's going to look. So I'm just going to set the alignment to center and the V alignment to center. And I'm going to set the size to 1700 on the width and 1300 on the height. Now we're going to hit layout up here, and we're going to set the top wide. Now we're going to manually set the width though in the X position. We're going to set this to 1700. And this just is a small enough value that it will fit inside this panel. So that's why I'm doing it smaller than the full screen. And then we'll set the size on the Y to 130. And we'll set the minimum size on the Y to 130. That way, when we start throwing them into this VBox container, they'll actually have their minimum size and they won't be squished down. Now I'm going to add a child node. This child node is going to be a button. I'm going to rename this button to join button, and we're just going to set the text to join, and we're going to set our custom font as our base font, and we're going to go to the layout, and I'm going to set this to right wide, and I'm going to set the position on the X to 1398 and the position on the Y to 13. Now the size on the X I'm going to set to 302, and the size on the Y I'm going to set to 104. Every server that it finds will automatically fill out this information. Now I'm just going to go to node, and I'm going to add a group to this, and we're just going to call this server display. We're going to use this group later, and make sure you have this named correctly or else it won't work. We're going to attach a script to this. I'm just going to call it server display.gd. On the join button, we are going to connect the press signal back to the server display, and this will go back to the script. We'll make an IP address variable. Will just equal an empty string. And when the join button is pressed, we want to set the network.IP address to this empty string, which will actually be replaced with the IP address that it is assigned to that current server. When we find this current server, it'll fill out all of this information automatically, and it will set the IP address to that corresponding address. So we won't be joining a blank address when we hit the join button. But for right now, it'll just be blank. The network will join the server. We'll do get parent.getParent queue free. I just did this because get parent parent.getParent.QFree will just go all the way up to the server browser and just destroy it entirely. And I could save this, and we'll just call it serverdisplay.tscn. That's just fine. We hit save it. Now back into the server browser script, we're actually going to have to add the parameters right now. So since this was a custom signal, it didn't see the parameters, but we did have a parameter that we threw into it when we call the signal. So we're just going to call server info. When we call the signal, we do call it with the server info, and that's why we're going to have to set this parameter so we can access that. We're going to instance the server display for every new server that the server listener gets, and so we'll get a reference to it using the server node variable, and it will just be instanced under the server container, which is this VBox container, which will organize them all nicely for us. We'll set the text of this server node to our server info.ip and our server info.name, which will be transferred whenever we call the signal. This text will basically be the same as this server display right here. It will set the server node's text, which is this server display, to the IP address of the host and the name of the host. We'll set the IP address of the server node to the string of the server info.ip address. When we are advertising the server on the host, when the client is here, the server browser will receive that, and it will say, hey, this IP address needs to equal that string address that we just received for that host, because that host just hosted that server, and we need to make sure that that corresponding IP address is equal to that, so then when we hit the join button, it will actually be able to connect to that IP address. All right, this one also had an argument that was sent whenever the server is destroyed. We send the server IP. So just make sure that you have the server IP right here as an argument. That way you can actually access that when we are trying to destroy the server. So we'll go through all the server nodes and the server container's children. We'll make sure that the child node that we are currently iterating on is part of the server display group. And we'll make sure that the IP address is equal to the server IP. This IP address we assigned right here when we created that server. So if it's equal to that server IP of the server that we're trying to remove, we should remove this one because that's the same server as the one that just got cleaned up. So we just tell it to queue free and we do a break. So this will break the for loop because we just found that one server node, because there'll only be one, so there's no reason to keep iterating and checking every other node after that. We just want to make sure that we destroy that node and say, hey, we need to break this loop because we already found it. So in the server browser, we're going to connect the manual setup button pressed back to the server browser. So connect the press signal on the manual setup button and connect that back to the server browser. So when manual setup button is pressed, we're going to check if the text is not equal to exit setup. So this just makes sure when you press the manual setup button, it will change it to exit setup, the text on it. It's almost like a toggle, right? So I hit manual setup and it shows us type in server IP. Let's say I want to exit the manual setup. Well, this button will change from manual setup to exit manual setup. And when I press exit manual setup, it will just hide the server IP text edit right here. We'll show the server IP text edit because we're manually putting in the server IP. We'll set the text to exit setup of the button. We'll hide the server container, which will hide all the servers in the background because we don't want to clutter the background. And this is something nice I just added. I set the server IP text edit and I called this deferred function grab focus. And what this essentially does is it's like focuses on the IP text edit, so I don't have to click on it to start putting in the text. It'll automatically be focused and I can start typing in it without clicking on the actual text edit. It's just a nice thing that you can add. Else, if the text is equal to exit setup, then we want to make sure that we'll reset the server IP text, because I could just exit the setup, leave the IP address in there, and if I went back into the setup, the IP address would still be there. So I just reset IP address text edit and I hide the server IP text edit, so it hides all these elements right here. We'll set our manual setup button.text to manual setup saying, hey, if you click on this button again now, it will go back to manual setup because you just exited the setup. And we'll show all the servers in here. So this will just go back into the automatic server list. So go back to here and we're going to connect the join server button. When you type in the server IP, we want to be able to join it manually. So we're going to connect this join server button back to server browser. And when join server is pressed, we're going to set our network IP address equal to server IP, the server text edit dot text. So whatever we put into this server IP text and we hit join server, we'll set the current network.ip address to it. Then we'll hide everything. This will hide the entire server browser and we'll join the server. If you press this go back button, we're essentially going back to this first network setup scene. We're going to get the press function, I'm going to connect out the server browser. If you hit the back button, you want to go all the way back to the start. Technically, so go back to network.gd, and then when we create the server, we want to instance the server advertiser. Global will instance the node, load the server advertiser node, and we'll just instance it under the current scene. So this will basically say, hey, if you decide to host the game, now we're going to start advertising the server of our game. And the server listener is already in the server browser, because whenever you are joining a game, you automatically are going to have this in here. If I try to do this all over localhost, it will not see the game. I can create one game. I'll create a server and I'll say, hey, I want to join the server. It's never going to find the server. It's going to tell you on Godot, it's going to say, hey, there's an error listening to this port, because this port is already taken by this current machine. As I would test this on 2 different devices. You go project export. I'll just add the Windows preset, and you want to make sure that you install the export templates and have those downloaded, and then you just export to Windows and hit export project. Now for Android, when you test your game on Android, you want to scroll all the way down through all the permissions, and you want to make sure internet is checked. For the server browser, you want to make sure that the change Wi-Fi multicast state, make sure that this permission is ticked. So just go on and export it, and you can test it.